Hello, today we're going to get into relations and functions. These are the different words we're going to look at today: function, relation, domain, dependent variable, one-to-one, independent variable, and range. Please keep an eye out for these words throughout this lesson. Let's look at the basic terms for describing ordered pairs. We have a relation. A relation is a set of ordered pairs like you see here. One ordered pair takes the form of x and y. So a set of ordered pairs would be a relation. We also have what is known as a domain and range. The domain is the first set of elements. More specifically, it is the x values. The range is the second set of elements, more specifically the y values. So, as you can see here, we start with a relation, and we are able to differentiate the x values and the y values, with the x values are all those in red, and the y values are all those in purple. Let's further look at an example. Here we have a chart that contains a domain and a range. More specifically, the x values are the states and the y values are the capitals. So if we wanted to create a set of ordered pairs or relation out of this, what we need to go ahead and do is connect one x value to one y value. This goes from states to the capitals, so the capital of Alabama is Montgomery, the capital of Alaska, and the capital of Arizona. Let's dive a little deeper. So, like we said, the domain is the x values, while the range are the y values. So a strategy for identifying the domain is to identify the x values that can be plugged into the equation, or identify the x values that are in the graph. So if we were going to look for the domain of a graph, we would identify the x values of those graphs. If we were going to find the domain in a table, we would look at this side of the table. And if we want to identify the x values or the domain in an ordered pair, we would look at the first set of values. If we wanted to look for the range, we would look at the y values. We look at the y of each of the ordered pairs, and we would look at the y side of the table. Now let's look more at a function. What is a function? A function is a relation in which each domain element is paired with exactly one range element. More specifically, we can remember this by using this idea. For every x, there is exactly one y. So every x value has exactly one y value. And so let's see what this looks like. Well, here we have our set of x values. And as you can see, the x value -6 is paired to one y value. The x value -3 is paired to two y values, -2 and -4. And the domain x value 1 is paired to 3. Because the x value -3 is paired to two y values, this makes it no longer a function. So not a function. In order for a relation to be a function, every x has to pair to exactly one y. And so here we have an example of a function. -1 pairs to -3, 0 pairs to -1, 1 pairs to 1, and 2 pairs to 5. So as you can see, each value of x pairs to exactly one y. Okay, the next thing we're going to go ahead and do is we're going to go ahead and look at a function. We're going to look at a function and identify what happens when we put an input into that function. So here's our function. Y equals x squared minus 1. So what you want to do whenever you're working with a function is identify the input. What are you putting into the function? So, for example, sorry guys. Let's say I have a function and I input the value 5. So 5 goes into my function. So I'm putting 5 into my function, y equals x squared minus 1. Basically what that looks like is us plugging in 5 for x. And what you want to do is you want to solve in order to find out your output. So this basically means 5 times 5. So that is 25 minus 1, which is equal to 24. So then that gives me my output. That gives me my output. Which will be 24. So basically a function, like we said, for every input, we get exactly one output. For every y, we get exactly one x. And so this is how we would represent this function. Now we're going to look at how to determine if we have a function in a graph. Well, in order for us to have a function in a graph, the graph needs to pass the vertical line test. And the vertical line test basically shows us that for every x, there is exactly one y, like we looked at before. So you have to use the vertical line test to identify if something is in fact a function. So let me draw those vertical lines. And the vertical lines run up and down. And I'll show you an easy way to remember this in just a second. Okay. And basically what this shows us is when we're doing the vertical line test, we want to make sure that if something is a function, that there are no repeated coordinates on those vertical lines. So for example, on this line, there's one coordinate. On this line, 1. This line, there's 2 coordinates. And so that's a problem because that means for that specific x value, there's more than one y, so that wouldn't be a function. But we can keep looking. Here too, we run into a problem. And what we can see is there are in fact instances in which we have more than one y for a specific x value. And so that wouldn't be a function. The way to remember what vertical is, an easy way to do that, is if we look at the letter V, this side of the letter V runs up and down. So vertical, up and down. Next thing we're going to look at is horizontal. And the way you can remember that and differentiate between the two is horizontal. Think of that center of the H. And thus it will run left and right. Okay. So when we use the horizontal line test, well, there's such thing as a 1-to-1. And a 1-to-1 is basically for every y, there is exactly one x. So instead of for every x, there's exactly one y, this one says for every y, there's exactly one x. And so in this one, we're going to use the horizontal line test. So we're going to draw lines horizontally. And if we have lines that contain 2 coordinates, then that wouldn't be a 1-to-1. So let me draw those lines. And so we want to see if there's any repeated coordinates on each of those lines. And as we can see, there are in fact repeating coordinates on almost every line. And so that would mean that this isn't a one-to-one function, because for every y, there is more than one x. So if I were to look at my y, I would see that there's more than one x for almost every y, and so that's not a one-to-one function. However, if I wanted to see if this was a function, it's not a one-to-one, but if it's a function, we'll do the vertical line test we did earlier. And we want to make sure if it is a function, then for every x, there's exactly one y. So we want to make sure every line has only one coordinate on it. 1, 1, 1, 1, 1, 1, 1. And so we see for every vertical line, there's exactly one coordinate on each of those lines. And so it might be a function, but this one is not a one-to-one function. Okay, let's go ahead and move on. So now we're going to look at function notation. And function notation is fairly simple. And what the function notation does is it takes an original equation and creates it into a function. So what it basically does is it takes our original y and it changes it to f to the function of x, so whatever x is. So, for example, if we're looking for the function of -2, that basically means we have f minus 2. And what you would do is you would plug in that x, the function of -2, so -2 into your x value. And then you would solve it, and then you would see that the function of -2 is equal to 3. And what you can see here on this graph is that -2 is equal to 3. So that's just a notation for how to write a function. And whenever you look at the graph, you will also substitute the y. So instead of x and y, you'll go x minus the function of whatever x is, or what the output of the function of x is. And then your tables, instead of x and y being represented on the table, you have x and the function of x. So those are just ways to represent those functions. Okay. So let's go ahead and use what we learned today about functions to create a function for a real-world scenario. So here this says tickets to a play cost $15 each. Write a function for the cost of X tickets. So X would be our input. We don't know exactly how many tickets, we just know it's X. Our output would be the cost of that X, so Fx. And then our relationship would be how much is each X, so 15X. For every ticket X, we pay $15. And then you can write this into a function by going ahead and putting those two together. So Fx is equal to the relationship 15x. And so you could solve for any x what the price would be. So for example, if I wanted to find the function of three tickets, then I would do 15 times 3 is 45. So I know that for 3 tickets, the function of 3 tickets is equal to $45. Okay, so that's basically the gist of what we are going over today. So let's do a brief review. A relation is a set of ordered pairs. So ordered pairs start with, ordered pairs start with x and y, and so a relation would just be a set of those pairs. So x and y, where x and y are actual values, of course. What is the domain? The domain is the input, or all the x values. The range is the output, or all the y values. And then we looked at a function. A function sends each input to exactly one output, or more specifically, for every x, there is exactly one y. And we could use the vertical line test to test this when looking for if a graph is a function. Then we have a one-to-one function, which basically says pairs each output with exactly one input. So for every y, there is exactly one x. And if you were to identify this in a graph, then you would use the horizontal line test. Okay, so let's look further at how to determine a relation as a function. Well, if you're looking at a mapping diagram, you want to make sure every input has only one output. For tables and lists, you want to make sure there are no repeating x values. For graphs, you want to use the vertical line test. To determine if something is a one-to-one function, for mapping diagrams, you want to make sure every output has only one input. For tables and lists, you want to make sure there are no repeating y values. And for graphs, you want to use the vertical line test. And then to write a function, you're going to identify the relationship between the independent and the dependent, so between the x and the y, and then use the function notation to write the function rule or the function equation. So that's the gist of everything we are going over today, and I look forward to seeing you tomorrow.